Now that we're exploring visual illusion studies, let's take a look at the Delboeuf illusion. So, what do you notice about these two red circles? Which one is bigger? They might seem different in size when in fact they are identical. Why is this so, and how does it work? We know that in humans there are both contrast and assimilation effects. Contrast is the phenomenon according to which the perceptual differences between two figures are enhanced. Looking at the smaller red circle vis-a-vis the larger white one, it's as if the smaller red circle becomes even smaller when put closer to the white one. On the other hand, assimilation is the opposite phenomenon, according to which the perception of two figures assimilates. One figure looks like the other in size. For instance, through assimilation, we might see these figures similar to each other in size as soon as they are close together. Well, in the Delboeuf illusion, we have both these effects. The stimulus on the left contrasts with the outer ring, while the stimulus on the right assimilates the properties of the outer ring. So how can we investigate this using free choice tests? Remember, in free choice tests, we use biologically relevant stimuli and we observe their spontaneous preference. This illusion works very well with food because it is well known that if we present the same amount of food in both a large and a small plate, we believe there is more food in the smaller one, right? This is indeed what Parrish and Barron have done with chimps. In some trials, they presented a large and a small amount of food, and they found that chimpanzees want to maximize food intake. Then, in test trials, they presented the same amount of food in a large and a small plate. And it was found that chimps prefer the food inserted in the small plate, much like humans. This very approach was then adopted at the University of Padua to investigate the same illusion in lemurs, dogs, lizards, and fish. Interestingly enough, varying perception of this illusion was found. While lizards showed a human-like perception of this illusion, dogs and lemurs do not perceive the illusion at all. But in particular, guppies showed curious behavior. When presented with the illusory pattern, they selected the amount of food on the larger plate. So they perceive a Delboeuf illusion, but in the opposite direction of humans. Take a look at the video of the experiment to see guppies in action. See that? A reverse illusion? To tell you the truth, guppies aren't the only ones. A reverse Delboeuf illusion has also been observed in pigeons and bamboo sharks. As was previously mentioned, this illusion works because of contrast and assimilation effects. In humans, we have both. However, if some species are poorly susceptible to contrast, they only have assimilation. Therefore, if they assimilate the stimulus on the right, the red one becomes slightly larger. But if they assimilate the stimulus on the left, this also becomes bigger, drastically bigger compared to the other one, thus leading to a size illusion, but in the opposite direction compared to humans. Clearly, if I want to use an animal model to study the perceptual mechanisms underlying size discrimination, I wouldn't use a guppy, given the differential perception of size exhibited in this experiment. With this example, you should realize how powerful visual illusions are as a non-invasive tool to investigate vision of non-human animals. Now that you know how Delboeuf illusions are observed in free choice tests, what about through training procedures? How can I study the Delboeuf illusion with a training procedure? Simple. First of all, I train my subjects to select the larger dot between a large and a small dot in order to receive a food reward. In these two examples, choosing the dots on the left are the larger of the two in each pair. Then, in the test phase, I introduce the illusory pattern. If subjects select a stimulus more than once, this means they perceive a size illusion. In particular, if they select the stimulus on the right, we have evidence of a human-like perception. If the opposite, we have evidence of a reverse illusion. Now that we've covered the Delboeuf illusion, let's move on to the next one on the list.